Okay, I want to remind you the difference between a prime number and a composite number. So, prime and composite. Prime numbers are always going to be odd, and they're going to be numbers that nothing can be divided evenly into. So, for example, if we have the number 9, can the number 9 be divided by anything? Well, sure. 9 can be divided by 3, and you get 3. So that is not a prime number. 7, is there any number that divides into 7? No. So 7 is called a prime number because nothing can be divided into it except 7 goes into itself and 1 goes into it. But other than itself and 1, nothing divides into it. So 7 would be a prime number. A composite number is all the other numbers. All the even numbers, because 2 can go into any even number, and also odd numbers that are not prime, like 9. 3 goes into 9 3 times, so it means it's composite. Alright, so when we're trying to solve problems, we're trying to make life as easy as possible for us, and sometimes that means we have to use some different methods in order to make our life easier when it comes to math. So, what we're going to do is, and another thing about prime numbers. Prime numbers are only positive. Okay, so just so you are aware of that. And I said that composite numbers are even and prime numbers are odd. The number 2 is the only even number that's also prime because nothing goes into 2 except itself and the number 1. So that makes 2 a prime number. So that's the only exception there when it comes to that. Alright, so one of the things that you've learned is you've learned that you have factors of certain numbers that are not prime. Like the number 12. You can factor 12 down into 6 times 2. It'll also factor down into 4 times 3. And it'll factor down into 12 times 1. But we won't worry about that one. We can have 16, and it factors down into 8 times 2 and 4 times 4. If we have 18, that factors down into 2 times 9 and 6 times 3. Okay, so those are factors. Two numbers multiplied together that will give us our original number here. When we talk about prime factors, that means that we're looking for numbers that multiplied together, like 6 times 2, give us 12, but those numbers that we're multiplying are prime. So if we took 6 times 2, 2 is a prime number, but 6 is not. So we have to factor 6 down and see if it can be factored. And it can, 3 times 2. Now, is 3 and 2 a prime number? Yes, they're both prime numbers, so that means we have the product of the primes, or we have the prime factors. These are the factors multiplied together that give me 12, and each one of those factors is a prime number. This becomes very, very important when we're talking about reducing things. So let's look at 60. 60 reduces to 6 times 10. Are either one of those prime? No. So this one is 3 times 2, and this one is 5 times 2. So all 4 of those numbers, if we were to multiply them, we would get 60. So these are the prime factors of 60. All of the numbers, and there might be a whole slew of them, multiplied together to get 60, and each one of those numbers is a prime number. And what I do, and you've learned this before, I'm sure, is the factor tree. So if I have a number like 60, I would do this. All right, what two numbers multiplied together to give me 60? 6 and 10. Are those prime? No. So I'm going to factor this one down to 3 and 2. Are those prime? Yes. So I'm going to circle them to tell me that I'm done. 10. Is it prime? No. 2 and 5. Are those prime? Yes. And then when I'm done, when I have no other numbers to factor, I just put everything I have circled together. And those are my prime factors. Now I prefer they be written in numerical order here, like that. And if you even want to be cooler, you can take that 2 times 2 and make it 2 squared. And those are your product of primes. Alright, so let's look at one that's bigger. Example 12 gives us 630. 630. So it's an even number, so I'm going to just write it as 315 times 2, because I can just divide it in half, and that's a prime number, so I know I'm done there. This ends in 5, so I know that 5 goes evenly into 315. And let's see how many times it does that. Okay, 63 times 5. Is 63 a prime number? No. Is 5? Yes, so I'll circle it. Because 63, 9, and 7 go into it. Is 9 prime? No. Is 7? Yes. 9 breaks down to 3 and 3, and both of those are prime. So if I write these in order, 2 times 3 squared times 5, because I'm cool, times 7. Alright, so that gives you 2 times 3 squared times 5 times 7. These are the product of primes for 630. So when they ask for the product of primes, that's what they want. Alright, so how does this work in the real world? Let's look at a nasty looking fraction, example 13. We have 210 and we're over 231. And we're interested in the reducing this. Well, if we take the product of primes, we can do that. So let's take 210 and take that one, and then we'll take 231 and break that one down. So we have to do both of them. So 210, let's see, 70 and 3. 3 is prime, so I circle it. 70 is 10 and 7, that's prime. This is going to be 5 and 2. So there I go. 210, the numbers I'm going to put on top are 2 times 3 times 5 times 7. Let's break 231 down. One of the things that's good to know is if you take a number like this and you add up the digits, 2 plus 3 is 5 plus 1 is 6. And if 3 will go into that answer, 2 plus 3 plus 1, then 3 will also go into this. So I know automatically that since 3 goes into 6, I can take 3 into this 77 times. So 77 times 3, and 3 is prime. Let's see, 11 and 7. Are those prime? Yep, both of them are prime. 3 times 7 times 11. Alright, so what does that give to me? That gives me a product of primes on the top and the bottom. That means if I see a number similar, or the same number on top as I do on the bottom, I can cancel. Cancel that with cancel that. And that gives me an answer of 10 over 11, and that will always be the reduced number. You don't have to go, oh, I wonder if that's the smallest it goes. It will always be the smallest it goes if you do it this way. And that's it for lesson 1.8.